Hello class, today we're going to look at converting from fractions to decimals and then back from decimals to fractions and kind of how that process works. Now, this is a very easy process if you're using a calculator, especially the TI Series 84, which we use a lot in our introductory classes here at the University of South Carolina, Aiken. But you need to know the process behind what that calculator is doing, and that's what we're here to refresh today, so that you can make sure you know what you're doing. We're going to start out by converting from fractions to decimals. To me, that's the easiest process to start with, and then we'll look at converting back from decimals to fractions. So, we'll start out with this first worksheet here. It says convert the following fractions to decimals. Now, the whole process of converting fractions to decimals is just a division process. So, if I look at 3/10, all I have to do to convert this to a decimal is take the bottom number and divide it into the top number. 10 divided into 3. Okay, it's essentially all a fraction is a division. Now obviously 10 can't go into 3, so what I need to do here is add a decimal and a 0. And then I can say, okay, well 10 can't go into 3, but 10 can definitely go into 30. So because 10 can't go into 3, I'm going to put a 0 on top of the 3, and I'm also going to align my decimal. Okay, got to keep that decimal in that same place here when we're dividing. And now, 10 goes into 30 how many times? Well, 10 goes into 30 3 times. So, if we look at that, that zeroes everything out here. So, our conversion from 3/10 to a decimal is just 0.3. Okay, easy enough, right? 10s are pretty simple. We'll start out with some easy ones, and then we'll get progressively harder. Alright, let's look at number 2. Number 2 is 50 divided by 100. And we want to put that in terms of a decimal instead of a fraction. So we're going to take 100, and we're going to divide that into 50. Now, 100 won't go into 5. 100 won't go into 0. So, 100 won't go into 50. I guess would be a better way to say it. But 100 won't go into 50, so I need to add a 0. Now, 100 will go into 500. Remember, keep your decimal in the same location, so I'm going to put a decimal here so it lines up. Now, 100 goes into 500 5 times. 100 times 5 is 500. So, I can now subtract this off, and we're looking at a 0 here. So, we have a 0 remainder, so our answer here is 0.5. So, we've converted 50 over 100 to 0.5. Simple so far, right? All right, let's keep going. Alright, number 3 says 48 over 100. And if you notice, all the ones that we're going to start out with are either 10s or 100s, just to be easy and simple. And then we'll get into some more complicated ones in just a bit. Alright, now 48 divided by 100 is essentially what we're doing. So I'm going to take the 100, divide that into 48. Obviously 100 won't go into 4, and 100 won't go into 48. So 0 zeros here. I'm going to add a decimal and a 0 here. And I'm going to line that decimal up here in my top. Now, 100 does go into 480. Doesn't go into it perfectly, but it does go into it. So 100 goes into 480 4 times. 100 times 4 is 400. So I'm going to subtract this off, and I'm going to get a remainder of 80. Well, we don't want a remainder. We have to completely zero it out here. So I'm going to add an additional 0, and I'm going to bring it down. Now 100 divides into, or goes into 800 how many times? 8 times. Okay, and that will completely zero it out here. So our answer here, 48 out of 100, is 0.48. Okay. Now this should kind of make sense for your 10s and your 100s. Okay. Now, basically, we have 48 in the hundredths place. If I scroll back up, here I have, technically, this is the same thing as 50 in the hundredths place, or even 5 in the tenths place, which is the same thing as 50 in the hundredths place. And for number 1, I have 3 in the tenths place. 3 in the tenths place. Okay? Easy check there if you're messing with tens, hundredths, thousandths, anything with a nice 0 at the end, or just zeros or ones and zeros. Okay, let's see if we can figure out number 4. Here I have 17 tenths. 17 tenths. So I'm going to divide 10 into 17. Now 10 won't go into 1, but 10 will go into 17 one time. But in doing so, we're going to have a remainder of 7. And like I said, we're not okay with remainders. We want to completely get rid of them. So we're going to add a decimal and a 0. Keep the decimal same right there in that numerator right there. And now here, we're going to bring that 0 down. How many times does 10 go into 70? It goes 7 times, and there it will 0 it out. So 17 over 10 is the same thing as 1.7, or 17 in the 10th place, technically. 17 in the 10th place. Remember, this is the 10th place here. This is the 100th place. Okay. All right. So, kind of getting the flow of this. I'm going to have to erase some of my work here in order to do the next couple problems. So, if you need to see what this work is and you hadn't written it down on your own, go back and do so. I'm just creating some space for myself. If you need a scratch sheet of paper to work this out to the side, that's perfectly fine too. But like I said, I just need to create some space for myself so that we can continue this on this worksheet. Alright, number 5. I have 26 tenths. 26 tenths. Okay, so with this, I'm dividing 10 into 26. 10 will go into 26 because it'll go 2 times. 10 times 2 is 20, which leaves us with a remainder of 6. But remember, we're not okay with the remainder, so I have to add a decimal to 0. Bring the 0 down. 10 goes into 60 6 times, and that will 0 this out with 0 remainder. So 26 tenths is the same as 2.6. Nice. Now, 5/100ths. Now, if we use the logic here, I'm just going to see if you can put a little bit of this together for some of these simple problems. If we use the logic here, 5/100ths should mean that we have a 5 in the 100th place here. Remember, the 100th place is the second one after the decimal. Okay, that's what it should be if we're kind of building on what we're doing here. But we can check ourselves. We can divide 100 into 5. Keep in mind, 100 won't go into 5, so we've got a 0 there. I add a decimal 0. 100 won't go into 50 either, so I need to add another 0. And 100 will now go into 500 5 times. 100 times 5 is 500. Subtract those 2 there. And you can as well see we have 0.05. Okay, very nice. Once again, do a little erasing here just so I can have a little bit of space to work this other problem. But I encourage you not to erase your work. But all I have to work with here is one screen. Now, we're looking at 75/100ths. Following the logic, because we're using a base of 100, this should be 0.75. Hopefully you're kind of gathering that by now. But you can check it by dividing 100 into 75. I need to add a decimal 0 here. 100 goes into 750. 100 goes into 750 one time. Remember, won't go into 7, won't go into 75, so I have to move it over here. Now, that'll leave a remainder of 50, which means we need to add an additional 0 here and bring it down so that 100 goes into 500 5 times. Oops, that 7 didn't show up very good, did it? And then that finally subtracts out to give you your 0 remainder. So we are indeed correct. 1/10, if we follow our logic here, we should have a 1 in the 10th place for our decimal. You could check it by dividing 10 into 1. 10 won't go into 1, so I put a 0, and I drop a 0 here on the end of the 1 after the decimal place, and 10 will go into 10 one time, so that we have a 0 remainder, and our answer is indeed 0.1. In college, we don't really mess with remainders. We want the full decimal, or we want the fraction, one or the other, and we will tell you what we want. Let's look at this set of problems here. Okay, in this set of problems, it says match each fraction with its equivalent decimal. Now, hopefully you can line them up and see what they're going to be, but we'll check them real quick. So go ahead and take an attempt real quick in trying these and lining them up, and then we'll check your answers. So with the first one, 62/10, all you're really doing is dividing 62 by 10. 10 will go into 62 6 times. Gives you a remainder of 2, but remember we don't want remainders, so we have to add a decimal 0 and bring the 0 down. 10 will go into 20. 10 will go into 20 2 times, but we have to keep that decimal in that location till it zeroes out, and we're looking at 6.2. Boom, there we go. Now, change my color here. We have 4 hundredths, so 4 divided by 100. 100 will not go into 4, will not go into 40, but it will go into 400 4 times, and that'll leave you with no remainder. So obviously 4 divided by 100, or 4 over 100 as your fraction, is 0.04. And now we've got 39 tenths. 39 tenths. I think you can obviously see where this is going. 10 divided into 39. Okay. 10 will go into 39 3 times. And if we do 39 minus 30, because 10 times 3 is 30, we get a remainder of 9, which means we need to add a decimal 0 and bring the 0 down. And then 10 goes into 90 9 times. So I'm looking at 39 tenths. It's the same thing as 3.9. Alright, let's look at question C. Which of the following is the decimal equivalent of 6 over 100? Okay. Now, 6 over 100. 6 in the hundredth place. Okay, we don't have 2 6's. We don't have a 0.16. Now, 6 in the hundredth place. So obviously, these two are no-goes. 6 in the hundredth place. Remember, this is the tenths place. The second one is the hundredths place. So I'm doing 100 divided into 6. So remember, it won't go into 6 there. So we have to add a 0. 100 also won't go into 60. So we're going to have to add an additional 0. And then we can see that 100 goes into 600 6 times. And that's where we get the 0.06. Okay, so let's finish this up here. So this would be 0.06. Alright, so let's make it a little more difficult. Let's give us some denominators that aren't necessarily tens or hundreds, okay, and convert a few of these. Now here I have 2/4. Okay, it's going to work the same way. The process is the same. I'm going to divide 4 into 2. Okay, obviously 4 doesn't go into 2, so if I add a decimal 0 here, 4 will go into 20 how many times? 4 will go into 25 times. And I did not give enough space for that, did I? Decimal 5. So we're really looking at the answer here of 0.5. You can't just throw the number in this case into a region like we were doing above with the tenths and the hundredths place. But you can still find the answer by a simple division. Now let's look at 1/2. Okay, 2 divided into 1. 2 won't go into 1, so I need to add a decimal 0. 2 will go into 10 5 times. So I'm looking at 0.5. Now hopefully you notice that 2/4 does reduce down to 1/2. So the number 1 and number 2 are essentially equivalent here. And we could have simplified if we needed to. Excuse me. Give me a little drink of water. Alright, let's look at 6/25. 6/25 here. So now we need to divide 25 into 6. Now, will 25 go into 6? It will not. So we need to add a decimal 0 here. Okay, 25 will go into 62 times. 25 times 2 is 50. So we'll subtract that away from the 60 and see what we have remaining. We have 10 remaining. We don't want a remainder, so we need to add a 0 here and then bring the 0 down. 25 goes into 100 4 times. 25 times 4 is 100. So that gives us the remainder of 0 we were hoping for. And our answer here is 0.24. So we have converted the fraction of 6/25 into 0.24. Now, because we did an entire worksheet on tenths and hundredths places here, I'm going to go ahead and use the facts that we learned from that last worksheet in this worksheet. This is 23/100ths. So hopefully we don't even have to do the division here. We can just say, okay, this is 23 in the hundredths place. So 0.23. Easy enough. Let's look at 2/5. So 5 divided into 2. Obviously 5 won't go into 2. But if I add a decimal 0, 5 will go into 20. 5 will go into 20 4 times. 5 times 4 is 20. So I subtract out here and have a 0 remainder. So my answer for this one is 0.4. Very nice. Now 6 is 4/10. So a 4 in the tenths place. That's 0.4. Easy enough. Number 7, I have 19/20ths. So I'm going to divide 20 into 19. Oh, getting a little more difficult here. Obviously 20 doesn't go into 19, but 20 will go into 190. Now, how many times will 20 go into 190 is the question. It should go 9 times. And 9 times 20 is 180, which means if I subtract this, I should have a remainder of 10. We don't want a remainder of 10, so we need to add a 0 and bring it down. 20 goes into 100 5 times. 5 times 20 is 100, which gives us the remainder of 0, which gives us our answer here of 0.95 for number 7. That one was a little more difficult, but easily doable with a simple division. How about 48/50ths? 48 out of 50. I'm going to divide 50 into 48. Obviously 50 won't go into 48, so I'm going to add a decimal 0 here. 50 will go into 480 though. How many times? Let's do 9 times. 9 times 50 is 450. If I subtract this, it should leave me with a remainder of 30. We don't want a remainder, so we have to add another 0 here. And then we will bring that 0 down. 50 will go into 300 how many times? 6 times. So our answer here, because that will render us with a remainder of 0, our answer here is 0.96. Very good, very good. Okay, let's see what we got next. All right, 59/100ths. So I need to put 59 in the hundredths place. Boom. All right, how about 19/50ths? Okay, I'm going to divide 50 into 19. Obviously won't go into 19, so I need to add a decimal 0. Got a little ahead of myself there. How many times will 50 go into 190? Should go 3 times. 50 times 3 is 150, which leaves you with a remainder of 40, which means I need to add another 0 here and bring it down. 50 goes into 400 8 times. So we're looking at an answer here of 0.38. Very, very good. Okay. Let's change it up. 17/20ths. So I'm going to divide 20 into 17. Obviously won't go into 17, but 20 will go into 170. 8 times, because 20 times 8 is 160. So this leaves us with a remainder of 10. Remember to keep your 0 out front and your decimal places lined up. So how many times will 20 go into 100? Should go 5 times, right? And then 100 minus 100 is 0, because 20 times 5 is the 100. We have a remainder of 0, and our answer here is 0.85. Hopefully, as you continue with this course, you see the need to have your multiplication facts down. Because if you didn't have your multiplication facts down and weren't acutely familiar with them, then figuring out how many times 20 goes into 170 could be incredibly difficult if you couldn't break down into your mind that 2 times 8 is 16, and we add a 0 to the end, and that's as close as we can get to 170, because if we did 20 times 9, I'd wind up with 180, and that'd be too big, right? So you have to know your multiplication facts, and you have to know how to manipulate them within your mind. Otherwise, you and that calculator is going to be sitting there forever and a day on your tests and quizzes trying to figure out these extremely basic things that should be automatic. Number 12, 6/10 should just be 0.6. We should have 6 in the tenths place. Remember, the tenths place is the first place after the decimal. 31 100ths, another easy one, 0.31. I've got 31 in the hundredths place, the second place after the decimal. About 18 25ths. All right, I'm going to divide 25 into 18. Okay, obviously 25 won't go into 18, but 25 will go into 180. How many times? Anytime I see 25s, I think of quarters. And hopefully you can deal with quarters pretty quick, because a quarter is a function of money, right? So how many quarters will get you really, really close to $1.80 is immediately what goes to my mind. So there's 4 quarters in $1, so it's clearly over 4. And then 75 cents is as close as you're going to be able to get to it after that, so it should be 7, right? It should be 7. Now 25 times 7 should give you 175, or $1.75, if you want to look at it that way. This will give us a remainder of 5 here. I need to add a 0 because we don't want a remainder. How many times will 25 go into 50? Should go 2 times. So we're looking at 25 times 2, which is 50, which zeroes that out for us for a remainder. So our answer is 0.72. All right. Now, number 15, we'll stick with the money example. 1/4, or a quarter. 1/4, 1 quarter, 1/4, 1 quarter. What should this be? Should be 0.25 because it's a quarter. Don't believe me? Divide the 4 into 1. 4 won't go into 1, but it sure enough will go into 10 2 times, which will give you an 8 here, which gives you a remainder of 2. You add another 0, bring it down. 4 goes into 20 5 times, which causes your remainder to 0 out. And just like I said initially, a quarter is the same thing as 0.25. That's just simple money terms there. Simple money terms there. Gotta have that money, dude. Alright, 39 out of 50. Okay. So I'm going to divide 50 into 39. Clearly won't go into 39, but it will go into 390. How many times? Well, if I look at this here, let's see. So 50 cents into $1. It takes 2 of those for $1, and I got 3 of those total. So I'm looking at, what, 6, and then another one to get us there. So maybe 7. Or you can look at your factors of 5 and say, okay, what factor of 5 will get me closest to 39? 5 times 7 is 35, because 5 times 8 is 40, and that gives you over. So there's a couple different ways you could think about it in your mind to mentally multiply yourself up to it. We still have a remainder of 40 here, which is unacceptable. So we have to add a 0 here. And 50 goes into 400 8 times, because 5 times 8 is 40. So 50 just adds an extra 0. This is going to zero out our remainder for us and give us an answer of 0.78. Very nice. Okay, now we're looking at Now we're looking at 6/20ths. Okay, so I'm going to divide 20 into 6. 20 obviously won't go into 6, but if I add a 0 here, how many times does 20 go into 60? Should go 3 times, right? So I'm looking at 0.3. Now, 4/5. 4/5. How many times does 5 go into 4? 5 won't go into 4, so it goes 0 times. But if I add a 0, a decimal 0 here, 5 goes into 40 8 times. And you could subtract that out and see you have a remainder of 0, which is what we need to be done. So my answer is 0.8. And we have now converted from fractions to decimals. Now, that's all well and good. You could check your answers here on this next page if you wanted to do it on your own. But we've got to be able to go both directions here. We've got to be able to convert from a decimal back to a fraction as well. So how do we do this? Now this plays into the tenths, hundredths, thousandths, 10,000ths, depending on how big your decimal is. So if I look at this, what I want to do is figure out what the furthest decimal is and what place it sits in. Remember, one place after the decimal is your tenths place. So 1.9 is just 19 tenths. Okay, let's look at the next one. We do simplify if possible. Here you can't simplify. Now, if this is the tenths, the next one over is the hundredths. Okay, which means I need to put 7 over 100. Once again, simplify if possible. Here you can't. So we're done. We have now converted 2 fractions into 2 decimals. Simple as that. Or two decimals into 2 fractions. Sorry. It can get confusing. Alright, let's look at this one. The furthest decimal is in the hundredths place. Tenths, hundredths. Furthest decimal's in the hundredths place. So I need to put 21 over 100. Simplify if possible. Here we can't. So we're done. My furthest decimal is in the tenths place in this one. 9.3. Furthest decimal is in the tenths place. So I need to put 93 over 10. Can't reduce any further, so I'm done. Wow, real easy, right? 3.8. My furthest decimal is in the tenths place. So this is going to be 38 over 10. You can reduce this one. You can reduce this one. These both have a common factor of 2. So we are going to reduce our fraction here. 38 divided by 2 should give us what? 38 divided by 2 should give us 19. And 10 divided by 2 should give us 5. So we have it in simplest form. 6.1. Furthest decimal's in the 10th place, so I'm going to put it over 10. So that's 61 over 10. Can't simplify, so we're done. 2.9. Furthest decimal's in the 10th place, so that's just 29 tenths. 0.6. Tenths place. 6 tenths. We can reduce this one. They both have a factor of 2 in common. So I'm going to divide both by 2 to simplify. 6 divided by 2 is 3. 10 divided by 2 is 5. So 3/5 is our answer on that one. Easy enough, right? Just got to know what place that last decimal is in, and we're going to put it over that number. Alright, so for part B, match each decimal with its equivalent fraction here. Okay. For the first one, the furthest decimal, 5.1, is that 1, and it's in the tenths place. So I've got 51 tenths. Well, I can already see what that matches to. Alright, number 2, I have a 4. That's my furthest decimal, and it's in the hundredths place. So I need to put 4 over 100. Now, this can be reduced. Both can actually be reduced by a factor of 4. So I'm going to divide 4 by 4, which will give me 1. I'm going to divide 100 by 4, which will give me 25. So this is the same as 1/25. Now 0.8. This is 8 in the tenths place. So 8 tenths. Okay. This can also be reduced. They have a common factor of 2 that can be canceled out of both of them. 8 divided by 2 is 4. 10 divided by 2 is 5. I'm looking at 4/5. Very easy. Now C wants to know which of the following fractions is equivalent to 4.2. Okay, so we're converting 4.2 to a fraction. Let's just do it. Okay, that 2 is in the tenths place. So I need to put 42 over 10. Okay, then I can reduce. Okay, what goes into both of these? I know at least a factor of 2. So I'm going to divide them by 2. I'm going to divide both by 2. 10 divided by 2 is 5. 42 divided by 2 is 21. Looks like answer choice A. Let's continue on with some practice. We want to convert the following decimals to fractions. Okay, simplify if possible. Here we have a 7 in the tenths place, so this should be 7/10. Can't reduce it, so I'm done. This is 0.38. Furthest decimal's in the hundredths place, so this should be 38 over 100. I can indeed reduce this one. I know by a factor of 2. 38 divided by 2 should give us 19. And 100 divided by 2 gives us 50. And that's as far as I can reduce that one. Number 3 here is 0.1. Okay. That 1 is in the tenths place, so I'm looking at 1/10. Reduce if possible, and I cannot reduce. Alright, 0.61. That furthest decimal is that 1, and it's in the hundredths place. So I'm looking at 61 over 100. Reduce if possible. Here I can't reduce, so I'm done. 0.86. Okay, that 6 is in the hundredths place, so I'm looking at 86 out of 100. I can definitely reduce here. Now, if you don't know your factor of 86, you could start with the simplest one, say 2. 2 will definitely go into both. Okay, 86 divided by 2 is going to give you 43. 100 divided by 2 is going to give you 50. Okay. Now, do we have any further factors that go into both of these? I do not believe that we do, so we're done reducing. Now we have 0.6. That 6 is in the tenths place. This is just 6/10 here. Okay. I do need to be able to reduce this one. They can both reduce by a factor of 2. So this gives us 3/5. 0.33. That last 3 is in the hundredths place. So I'm putting 33 over 100. Can't reduce, so we're done. 0.27. That 7 is in the hundredths place, so I'm looking at 27 out of 100. Can't reduce that any further, so I'm done. Hopefully you see this pretty simple. 0.3. That 3 is in the tenths place, so that's 3/10. 0.4. That 4 is in the tenths place, but I can reduce here by a factor of 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So our reduction here brings us down to 2/5. How about 0.94? That 4 is in the hundredths place. So I'm looking at 94 out of 100. I do need to reduce here. I'm going to divide by 2 on both of these. So reduce by a factor of 2. 100 divided by 2 is 50. 94 divided by 2 is, what is that, 47. And that's as far as that one can reduce. About 0.45. That 5 is in the hundredths place. So this is 45 out of 100. I'm going to reduce both of these by a factor of 5. Okay. 45 divided by 5 is 9. 100 divided by 5 is 20. And that's as far as I can reduce that one. All right, a few more. 0.5. That 5 is in the tenths place. So this is just 5 out of 10. I can reduce that by a factor of 5. So I'm going to do that. Divide both of them by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. I've reduced 0.5 into 1/2 as a fraction. How about 0.49? That 9 lies in the hundredths place. So I'm putting 49 over 100. And I can't reduce, so I'm done. All right, let's look at 0.98. That 8 is in the hundredths place. That's just 98 out of 100. Okay. I can reduce these by a factor of 2. 98 divided by 2 is 49. 100 divided by 2 is 50. Okay, looking at 0.2. That's 2/10. I can reduce both of those by a factor of 2. 2 divided by 2 is 1. 10 divided by 2 is 5. I've reduced this down to 1/5. So, converting from a decimal to a fraction, not too hard. Converting from a fraction to a decimal, not too hard in the basic sense. You can make these more complicated, but I wanted you to know the basic sense behind what was going on here. Like I said, especially when you continue on into Math 108, you will be able to use a calculator, and you will be able to use the MathFrac option, and I'll explore those options on the calculator at the end of this class to help you familiarize yourself with a little bit of the calculator functions before you have to go into any of those collegiate courses. But you got to know the process behind it to know what the calculator is even doing so that you can make sense of the processes moving forward. Okay, because we will have to use some of these processes in solving for x in some of our equations. So your calculator is not going to be able to do that for you, so you have to know the basic processes that are behind all these mathematical functions we're doing. And most of them aren't very complicated at all if you just take the time to learn them. So, if you have any questions, reach out, let me know. Other than that, I will see y'all next lecture.